In this video, we're going to look at domain and range of a function that models a real-world situation. In our example, we're told that the fuel tank of a certain airplane can hold up to 300 gallons of fuel. Let capital W be the total weight of the airplane in pounds. Let capital F be the total amount of fuel in its tank in gallons. Suppose that W equals 5F plus 4,000 gives W as a function of F. So this is our relationship. W equals 5F plus 4,000. And we're asked to identify the domain and the range. So first of all, for the domain, we can either choose weight of the airplane in pounds or the amount of fuel in the airplane's tank in gallons. When we talk about the domain, we're talking about the input. And so what you want to do is think about what's the input in this equation and what's the output. So we can see that F is the variable being plugged into the equation. F is going to be the input in that equation. And so F represents the domain. They're telling us that F is the total amount of fuel in the tank in gallons. And so that's going to be the domain of my function, the amount of fuel in the airplane's tank in gallons. So I'll go ahead and cross out the weight here. Now the range is the output, or the result of the equation. And if we look at the way the equation is set up, it's W equals 5F plus 4,000. And so the W is going to be the output. Now in the statement, it says W is the total weight of the airplane in pounds. So I want to go ahead and select weight of the airplane in pounds for my range. And I'll go ahead and cross out the amount of fuel. So I've got my domain is the amount of fuel. The range is the weight of the airplane. And we want to figure out what set of values is reasonable for the domain and what set of values is reasonable for the range. Now, there's one key thing we're told. We're told that the fuel tank of a certain airplane can hold up to 300 gallons of fuel. It can't hold more than that. And so the amount of fuel in the tank has to be less than or equal to 300. Now we're talking about an amount of liquid. The fuel is a liquid. And so it would have to be greater than or equal to 0, because I can't have a negative amount of fuel in my tank. So the set of values would be 0 is less than or equal to F. And I should actually include some units here. So we're talking about gallons. And so I would say 0 gallons is less than or equal to F. F is the amount of fuel in the tank, which is less than or equal to 300 gallons. And you may have to select this in words. You may have to select the amount of fuel in the tank is between 0 and 300 gallons. Now for the range, we're talking about the weight of the airplane in pounds. So we know that our relationship here is W equals 5F plus 4,000. Now, the smallest amount of fuel in the tank would be 0 gallons. So if F equals 0, if F is 0, then I would have W equals 5 times 0 plus 4,000, or 0 plus 4,000. So the minimum weight of the plane is going to be 4,000 pounds, because we're told that W is the weight in pounds. Now I want to find the maximum possible weight of the plane if we're just looking at the fuel as the extra weight. So we'll have, if F is 300, then W is going to equal 5 times 300 plus 4,000. So that will give me 1,500 plus 4,000. If you need to put that in the calculator, you can just go over to Desmos, do 5 times 300 plus 4,000, and you get 5,500. So my maximum weight of the plane, just based on fuel, would be 5,500 pounds. And so I would have 4,000 pounds is less than or equal to W, which is less than or equal to 5,500 pounds. And you may need to write that in a sentence. You may need to say the weight of the plane is between 4,000 and 5,500 pounds inclusive of those endpoints. So the key idea here is that the domain is the input, the range is the output, and you're going to get the set of values based on something that's written in the original statement. So some restriction. In this case, the restriction was the tank could only hold 300 gallons of fuel. The weight, I'm going to take the minimum amount of fuel to find the minimum weight, and I'll take the maximum amount of fuel and plug it into the equation to find the maximum weight.